parallel force systems in that center of gravity. Let us look at this. Okay. Now here, this is not just parallel force system, it is parallel body force system would be better. Okay, it would be better to say parallel body force system because we are talking about body forces. What is meant by body forces? Body force determines the distribution of weight in a particular body. It's body force, is it not? Body force is determined by the distribution of weight. What is body force? Body force means the force that acts on the entire entire volume or body of the object. That is called the body force. The body force is the force that acts on the entire volume of the object. Right? Example is magnetic forces and then gravity forces. This acts entirely on the system itself, total system it acts, total volume it acts, correct? So now, if you consider a rigid body, okay, see, if you consider a rigid body, consider a rigid body, consider a rigid body, okay, whose density, whose density at every point, density at every point is given, whose density at every point is given as rho, some function density of x comma y comma z. Okay, so you have a rigid body whose density is given all over the body. It may not be the same, it may vary. Okay, but a rigid body is there where the density is varying with x, y, and z. It may remain constant also, but it may vary with x, y, z. Possible. Some alloy material can be there where the density of some alloy is somewhere different. At the top it is something different, at the bottom it is something different, or at the top it is higher, bottom it is lower, or bottom it is higher, top it is lower. We can always control that combination of alloying material, correct? So we can say more alloy material at one place, less alloy material at another place. So we can actually control the density of the metal on the macroscopic scale. Don't go for the microscopic. Okay, no atomic scale here. We are talking about macroscope. Okay, we are in continuum mechanics. This is part of continuum mechanics. Okay, so now this rigid body, this rigid body is acted upon by gravity. This rigid body is acted upon by gravity. Now, this gravity, okay, is a distributed parallel force, and this gravity force, this gravity, this gravity causes distributed distributed parallel forces, parallel parallel forces on the entire body, correct? Entire body. Okay, forces distributed parallel force system, I'll say. Okay, this gravity causes distributed parallel force on the entire body, or you can say force system here somewhere. Force system here on the entire body. There is a, at wherever the gravity is more, the density is more, the forces are more, because whatever the forces are there at that particular point depends on the forces at every point. So the force on the force of gravity at every point every point can be density, which is a function of x, y, z, into delta V small volume, correct, density into delta V small volume into G, correct, where delta V is the small elemental volume, and the direction also we can say K. We can say K. K, we are saying that it is the direction of the force which is acting, direction of the gravity forces, direction of gravity, correct. So that way we can say, if you say K, if I can put a minus K also. If I put in minus K, it's plus K, it's plus K, correct. It depends on whether you take gravity in the positive z axis or whether you take gravity in the negative z axis. If you take in the negative z axis, then this will be minus. If it is positive z axis, that will be plus. So let us consider K here as the z axis being positive downwards. But we have to keep in mind that we have considered the gravity force, the Z, in the direction of the gravity force. So do not miss, sometimes mathematics, we have to be flexible with mathematics and adjust it according to the physics. Okay, so if Z is positive upwards, then you have to take the force of gravity at every point can be minus rho delta V into G of K. If Z is in the direction of the gravity, then this will be positive, which I have considered now. Okay, I may change in the next problem only, but it should be intuitively you have to understand that I have changed. Now, only you have to comment on me if I've changed it in between a problem. First, I've considered it as a positive, but when I'm taking the problem, I've taken it otherwise. So, in one problem, I cannot take two different notations. I have to be consistent in one problem. Otherwise, I'll make mistakes. Okay. So, V is a small elemental volume. G is acceleration due to gravity. G is acceleration due to gravity. What is acceleration due to gravity? What is acceleration due to gravity? It is nothing but gravity force per unit mass. Is it not? What is acceleration due to gravity? It is gravity force per unit mass. This has to be very, very clear. Okay. So acceleration due to gravity is gravity force per unit mass. Done? Very good. Okay. Now, given this is the case, now what is the total force which is generated? Okay? The total force, the total resultant force on the entire body, on the entire body, Fr is equal to integration of, if I have taken positive as z axis, keep in mind, okay, integration of along the entire volume G into rho into dV into K. Correct? Keep in mind again, I have taken positive in the negative z axis. Downwards is positive. It's notation, it depends on how you want to see. So what happens? This can be written as equal to G into K, G into K into integration of volume into rho dV. You can see that. This is also equal to, I can say, minus of, I can also see it as G into this one can be written as integration of dm mass, where m is mass, dm, okay, into k. I can say that integration of dm into k. Or this can be equal to whatever the density changes at every point, the mass remains same. Mass is entire mass coming together, correct? So now this can be written as G into entire mass into K. So Fr is equal to M into G or G into M in the direction of K. So now we have the resultant force acting over the entire body. Now the question is, where does this resultant force act? So we have seen in simplest resultant that we can find out the force, total force, resultant force. But finding out the total force is not enough. We have to place this force in such a way that it does not cause any moment. Then it is the simplest resultant. If the force is zero, if the resultant force is zero, then what happens if the resultant force is zero? If the resultant force is zero, then a resultant couple has to be put. We have to see whether the resultant couple is active. If the resultant force is zero, resultant couple is zero, then the body is in equilibrium. Make sense? We are going through a simple thing. I'm reiterating again and again simple things. Why? Because in any complex problems, what we do mistakes is simple mistakes. So it's very important that we reiterate the simple things again and again. We'll make it so strong that it will be inside our subconscious mind, and by mistake also we will not do any mistake. Okay, so it's very important. Okay? So Fr is G into M into K. This is the force act. Now where does this act? It should act in such a way that there is no any any moment we can act, right? So let us see. Okay, with respect to x-axis and y-axis. So we have, say, z has to be in the lower direction. So we will have we'll set our x here, y here, and z downwards. Can happen. So we will say this is x, this is y, sorry, this is y, and this is z. Correct? X, y, and z. Z is in the lower direction. Correct? Makes sense. So now we have a rigid body here. In this one, it's back of this. This is back of it. Okay, it's in that. There is a rigid body there. Okay. Now, what should happen? The moments with respect to any axis should vanish, or the moment which is caused by these distributed force should be equal to the moment caused by this individual force Fr. Then that is equivalent. I'll repeat again. The individual forces caused by rho dV into G. This is the individual force dF. Correct? This dF would be rho dV into G of K. Correct? Now these individual forces dF has to be replaced by F. Now, when it is replaced by F, where should we place this F? Where should we place this resultant force? This resultant force should be placed in such a way that the couple acting because of, or the moment acting about an axis with respect to any all the individual forces should be equal to the couple acting or the moment acting because of this one force. I'll repeat again. The couple acting or the moment, the total moment acting, total moment about an axis or total moment these individual forces are applying on one axis should be equal to the moment generated by this one force acting at a particular point. Which force magnitude is given, but where it is acting is not given. So what should happen in case if I say I have to say this way? I have to say Fr, the resultant force Fr into y bar. This is about x-axis. I'll place this at x bar y bar. If I say I have to suppose this in case, okay, we'll say I will write down because notes is important. Okay, this force Fr placed at a point x bar comma y bar will generate the same moment as this force Fr placed at a point x bar y bar will generate the same moment. Z bar is there, but Z bar can go anywhere because we are with respect to x and y. Let us say, okay, will generate the same moment as the individual elemental forces dF, which is equal to rho g dV k, only when I'll write the thing in the next slide. Write this down. Okay, only when, let me write it here. Okay, only when Fr into y bar is equal to g into integration of along the volume into y, because you're taking the moment of these individual forces, y into rho dV, correct? And I'll write it here again. Fr into x bar is equal to g into integration of x rho dV across the entire volume. Correct? Yeah.
When we are taking that individual forces, that movement we are considering.
We can see actually when you say equilibrium, when you say equivalent force system, when I put an equivalent force system at a particular point, the moment at any point generated by these small individual forces should be equal to the moment generated by this new force which I am repeating. Now I am replacing small individual forces by one single force. So the moment generated at any point because of this individual force or this equivalent force should be equal to the total moment generated by all these small forces. Then only it is equivalent, otherwise it is not equivalent. Correct? Because force system does two things. First thing what it does, it creates a push or a pull. Second thing what it generates a turning moment. It turns. Putting a force, you can turn, you can push and pull. This is what you can do with force. So when I am replacing this all these forces, small forces, it's like 100 people are pushing a rock. Now if one person has to push the rock in the same way, then he has to be a strong build. That's one thing. Second thing is that he has to act at a place so that the resultant can be done. It's like 100 small babies pushing a rock, it being replaced by one strong man pushing the rock in the same way as 100 small children. Make sense? So this is the strong man who is pushing it or pulling it or rotating it. This is small children. Okay, maybe 3-year-old, 4-year-old children who are pushing it from various places. This person should be so intelligent that that same equivalence has to be created. Then he should be so intelligent that he should know where should I push, how should I push, that where should I, how much should I push, how much should I push is generated by Fr. How much should that strong man rotate depends on what is x bar y bar, where he should place. Make sense? Clear? Okay.
What is origin?
We are not worried about it. We are not worried about it. You can take any origin for that. Arbitrary, you can take origin. Then also you'll get the same. We have not specified anything about the origin because we have specified haphazard type of volume, haphazard type of to say um, density variation. We said rho x y z. It varies as x y z. Okay, that means this is the most general case. Can be applied to anything and everything. Make sense? Shall we move further? Okay. That means my x bar, if I want to say, so therefore, you have to write it down, please write it. It's very important, writing it every single time. Because every single time my classes are different. Every time it is better. It continuously improves. Same thing happens to you also. Whenever you see the basics again and again, your basics continuously improves. And your basics are strong, the more repetition you do, the more better you are. And more better you are in the basics, much stronger you are in the advanced. The advanced cannot happen without properly, what do you say, knowing the basics. Nowadays, the problem is that rush people rush into advanced. They want, see, it's correct that we have to start in the 8th standard, we have to start in 6th standard. Very correct. Why? Because the repetitions will be higher. That is the only purpose why it is there. First and foremost, we have to understand. Okay? Why should we start early? Or gate we have to start in the second year, I see. Why should we start in the second year? Because there is repetition. There is more chances of thinking. Okay, whereas when you come in the final year, then what happens? Or you come in the after your engineering, what happens? Your what do you say, you are first two things happens. Okay, you are actually very tired at that time. Okay, you have come for a place. See, so you people are exceptions, but there are people who do not get any jobs. That's why they come. Okay, so when the person who does not get any job comes, he is in a mode of frustration. He is not in a mode of understanding. So a person, whenever he has to improve, he has to come in a mode of understanding. And don't think that life is very difficult and it is a competitive. It is competitive world. So competition can be taken in two ways. One is I have to do this faster. That is one type of competition. Second type of competition, I have to do it better. When you have to do it better, I feel that you'll have more amount of happiness in you because you're doing it better. When you're doing it faster, what happens? You'll have something, oh, this is not done. You're not living that life. You're not living that life. Somebody is telling us we will do that. You go in that direction. Somebody says we'll do that. You do that. It is not your inner say what it's saying. If somebody is doing that, so your friend is saying, chalo, you go there, you go there. Other friend is saying, we'll go there, you go there. That is not from inner transformation. It's not what you want. Okay, so capability building. GATE is about capability building. Now after this, your life is very strong because your basics are strong. I will show you in the LinkedIn profile. You can see my friends who my connections. You can see in LinkedIn, and you can see how they have grown. Take them as a role model. Day before yesterday, I put a role model. You see them as a role model. And life is not something which is people say is competitive. You have to do well. You have to do fast. No, fast you have to do, but fast you have to do in such a way that you utilize more time. But what is happening nowadays, let me tell you, one of the big thing what is happening is today most of the students are on YouTube, Facebook, as well as these a lot of friendships. Okay, our friends either e friends either you have to isolate friendship. You keep acquaintances. I'm not saying you should not keep acquaintances. You should keep acquaintances, keep professional acquaintance. That is about being focused. Until you're not focused, you'll not achieve anything. Focus is very important. That's an opportunity today because the whole world today is consumerist. They want to enjoy. Well, they want to enjoy. It is competitive, but a lot of distractions is there, and most of the people are distracted. So you can grow really very fast. Only thing is that you have to stop distraction. Do not go to such a place that it's a work because everybody does that. Don't do it something that everybody does. See whether it's actually needed, and then do. And I'll tell you, you will be sure short of success. Okay, sure. Next point. Okay. Now, therefore, therefore, we can say, therefore, we can say, x bar, x bar is equal to integration of x rho dv by mass m, total mass m. Correct? Because Fr is m. Correct? Am I correct here? What I am putting there? I am putting GMK. G is cancelled. Observe that. Previous one you see. I have to have a G here. and here I should have gm. Okay, let me write it here, g by gm, correct? That is equal to x bar, can be equal to integration along the volume x rho dv, because rho changes. I'm not taking it, observe here, I'm not taking the density outside the integration term. Why I am not taking it outside the integration term? Because I am not considering the density to be constant everywhere, because that is the most general case. Yeah, G I am putting it outside. If G changes at every point, which may be caused by electromagnetic forces or magnetic forces and gravity acting together, okay, that we are not considering. We are considering simple gravity only, then we can see this. And y bar is equal to g into integration of y rho dv divided by gm. So g cancels and you get y bar is equal to integration of y rho dv divided by m. Make sense? So this x bar y bar, this x bar y bar is called the center of gravity, is called the center of gravity. Sometimes we call it CG, or center of mass. Center of mass, we call it CM. There are a lot of times they use center of mass, or centroid, which is denoted by G. All are same. Centroid, center of gravity, center of mass. All these are same.
Still gravity.
Now, if gravity changes at every point, then what happens? That G has to come inside. That's all. And this G will not be cancelled.
But both center of gravity and center of mass will be different.
Center of gravity and center of mass will become different. True. Center of gravity and center of mass becomes different when, very important, when gravity changes everywhere. Very good point. Okay. So if gravity is different at every x comma y comma z, then CG and CM can be different. Otherwise, it is same. Okay, so it's very important. Note. Very important. If gravity is different at every x, y, z, gravity in the sense G. Okay, I have to write G. Very important. And when I say gravity, it means acceleration due to gravity, force per unit mass. If that is different at different points of the rigid body, then center of gravity may be different, can be different from center of mass. Otherwise, it is not. Now, centroid generally means center of volume. It just has to be kept in. So, no, centroid is generally related with areas, but even volume we consider centroid is generally with volume with constant density. Okay. So here centroid can be used with mass also. It is not a very strong term. It can be used loosely. Here also we can use centroid. Okay, but keep in mind people use it loosely. Okay, the center of mass, center of gravity, centroid. They use this. They use it loosely. Okay, people will say where will the centroid last? Okay. But strongly speaking, we have to say centroid for center of volume. Okay, which does not depend on the density variation. To say it strongly. Okay, so we have to understand what is there in general culture and what is strongly when you make sense out of it and say that is a bit different. Okay? So that's it. Okay. Now let us do a problem. Okay. Question. The question is like this: find the center of gravity Find the center of gravity of the triangular block having uniform density as shown in the figure. Online students, I hope you have written these down, correct?
Yes, sir.
Every time I'm doing the same problem, the repeaters have to do it fast. But whenever you do a new same problem again, you have to see the new facets of that. That is possible. Okay, it's a triangular block of say this distance. This distance, we will call it A, B, C, D. We will call it A, B, C, D, and let this be distance Z, or mm, let this be distance C, let this be distance B, let this be distance A. Let me use the same thing, which is the A, distance A, and let this be on this side from here till here. Let this be distance B. Okay. A, B, C. Can we do it, students? So A, B, C. Along the Y it is A, or yeah, along the Y it is A, along the X it is B, along the Z it is C. Now can we find out the total mass of this? Can you do it, students? The gravity is the same. Can you tell me what is the total mass of this triangular element? Can you tell me what is the total mass of this triangular element? Fast. The density is constant, so we don't have to worry. Correct? Online students, what is the total mass? Or the, yeah, total mass. What is the total mass? M. The mass of this triangular block is what? Tell me, students, fast. Others. Correct? Online students, what is the mass of the triangular block? Hello.
So density into ABs.
ABC divided by 2, is it not? Because it's a part of a rectangular parallelepiped, right? So what you have, the mass is equal to ABC into density divided by 2, correct? Agreed? So now the total force of gravity, the total force of gravity or weight of this body is Fr is equal to rho into G into ABC by 2. Correct? That is the total force of gravity or weight of this body. Correct? Now we have to find out the centroid of this. How will we do the centroid of this? We have to find out where the Y changes, where the X is there, and probably where the Z is there also. Correct? So all the three things we have to find out. Let us do that. Friends, can we find out A, B, C? Can we find out the X bar, Y bar, and Z bar? All the three we will find. Where should we act? Because there is a triangular element, is it not? So since it's a triangular element, we have to see in A, B as well as C. Can we do that, students? So now how do we do that is the question. Okay. See, then we have to go to the basics here. What is the basic? X into X bar is X into rho into dV by M. And Y bar is equal to Y into rho into dV by M. So let us find out X bar first. Correct? So X bar is X into rho, X bar is the distance of the X. Am I correct here? Wait a minute, students. Yes, I am correct because X is the distance from the Y axis. Very important. So here, very important here, one subtle element. This causes, this particular one causes moment about Y axis. I'll repeat again. This causes moment about Y axis, whereas this causes moment about X axis. Because Y bar is the perpendicular distance from the X axis. So Y bar into Gm causes moment about X axis. Understood? Is that clear, everybody? Students? Okay.
Yes, sir.
So that is very, very, very important that we understand that. So now let us see, X bar means we have to take distance from the Y axis. This is somewhere here, you say it is X bar, Y bar. So what is X bar? X bar is this distance, Y bar is this distance, Z bar is distance from the XY plane. Correct? This way we have to understand. So now if we have to consider the moment about X axis, the resultant force Fr must be placed in such a way that the moment of this Fr must about X axis must be same as the individual volumes, as the elemental masses. Correct? As the elemental masses. So what we will write? We will write here, see, this is going in the positive z axis, so G is in the negative z axis, so you say it is minus Fr into Y bar is equal to minus. Now how do you do the individual element? We have to understand. So one way to do the element is we will take a three-dimensional element and we integrate along three dimensions. That will be very, very difficult to do. Not difficult to do. There's an easier way to do it. What is the easier way? Take an element in such a way. Take an element whose y is the same all through. Okay. For example, if you consider an element something in this fashion, let us take an element here like this. This is a thing here like this, here this way, and here this way, and a small distance here, small element with a small thickness. You understand this? This is a small thickness element we are using, is it not? So let this be at a distance of y. Let this be at a distance of y, and we know this elemental volume, and this let it be the small thickness of this. Let this be dy. Very important to understand integration here. Okay, the problem happens we are not able to devise it in a proper way. Okay, so this would be integration of this small elemental volume. What is a small element? Small element, the distance to the small element y, and what is the volume of that? The volume of that is, if you understand that, it is b into c. Observe that it is b into c. Correct? Or is it b into c? No, it is b into z, because z is this length. I will call it as z. Let me call this length as z. a variable z, because it varies from this point to this point. Initially it is 0, it is going till that z is going till a particular value c, correct? This is c. It's going from 0 to c. Observe this particular one. It is going from 0 to c. So that, so it is y into b into z, y into b into z into dy, correct, into rho into g. Make sense? So what is happening here? This is very important to understand. Y z dy rho into g. Now this has to be integrated. From which point to which point? Now what are the variables here? What are the constants? Inside this integration term, what are the variables? What are the constants? Is y a constant? Is y a constant? No, it is not. Y is not a constant. So we cannot put it out of the, so because from here to here it is varying. Is b a constant? Yes, it is. As you take this elemental volume from 0 to that, from point, this point to this point here A, this B remains constant. So I can take B outside. Can I take Z outside? No, I cannot, because it is variable. Z varies from 0 till C. So I cannot take it outside. Then rho, is it same? It is said it is same. So I can take it outside. G, is it same? We can assume that it is same. So we can take it outside. So what is remaining here? You have y z dy inside the integration, and we can take b into rho into g outside. Make sense? So shall we do that? You have written it till here. Please write it down. Everybody has finished writing this? Have you understood this? So what I can do? I can write this as equal to minus of, I'll take out rho gb. I will take out rho gb, and inside the integration I will write, y z dy. Correct, students? Y z dy. Next point is how to represent z in terms of y or y in terms of z, because y is a function of z or z is a function of y. We cannot integrate until that function is not known. It is varying, but how does it vary? How is the functional relationship? That is very, very important. Correct? The same thing happens in thermodynamics. When we take integration of P dV, you should know how P varies with volume. Only then you can integrate. Make sense? So here we have to know how Y varies at Z. Then only you can integrate. Correct? So how does Y varies as Z? Or Z varies as Y? Then I can perform integration. Correct? Hello students. Correct? No? Agreed? So do tell me the relationship. Online students, please tell me the relationships. Tell me the relationship between Y and Z. Think. Very important. Yes, students, come on. Why are you delaying so much? Yeah.
So that triangular area.
Yes. So what is Y and Z? What to say, how does it? What is the functional relationship between those two? Can you tell me? Z is equal to Y tan theta. Okay. He has said something. Let us see that. He said, our Samarth said that Z is equal to y tan theta. Very good. But what is tan theta? Tan theta is nothing but y into c by a. Correct? Tan theta is C by A. So what is Z? Z is Y into C by A. Now apply that here and we find it out. So what will happen here? You will have this Y bar, or what we had here, minus FR into Y bar was, I will write this again, rho GB minus rho GB minus rho GB integration of y z dy, correct? And it, we know that z is equal to y tan theta, which is equal to y into b by, sorry, c by a, correct? It is c by a. So we'll substitute that here. We will have minus rho GB integration of y into c by a dy, which is equal to minus rho GB. Now we have got y. So we have to have the limits in terms of y, is it not? What are the limits in terms of y? It is from 0 to b. 0 to b, see the figure again, you will understand. 0 to b, y square into c by a dy. Make sense? Y square into c by a dy. Correct? Agreed? I've not done any mistakes here, I suppose. Correct? Okay, review. Don't say that Anantpai is not always right.
Sir,
0 to A or 0 to B is the question.
to
Okay?
A.
It is 0 to A. I'm very sorry. I made a mistake. It is 0 to A. And our students have correctly picked it. So it is 0 to A. 0 to A, y square C into dy. Correct? Let us integrate that. This becomes minus rho G into B. When we integrate y square or C by A, I will take it outside. So when you integrate, what will you get? When you integrate, you get y cube by 3, correct? You get y cube by 3 into, we have 0 to a, correct? So this minus fr into y bar is equal to rho g bc by a into y cube by 3. So this, what is fr here? What is fr? Fr is nothing but, we have already calculated, it is equal to minus Fr is rho g into ABC by 2, correct? Have we found out that? Correct? ABC by 2 into y bar is equal to minus rho g into BC by A, and here you get A cube by 3, correct? A cube by 3. So let us see what cancels what. So here we can write rho g, we can cancel, minus we can cancel, correct? A we cannot cancel, but BC we can cancel, correct? And this A comes down here, so y bar I can write it as, y bar I can write it as uh, 2 by 3, 2 by 3. Have I done any mistakes here, students? Huh? 2 by 3, and I can say here, okay, wait a minute. Yes. 2a, right? Do we get a here? Yes. 2 by 3a. Makes sense? This is my y bar. Easy. This is my y bar. 2 by 3a is the y bar. So we have done integration. We have done this. Now the same thing. Have you written down this? Write it down. Write it down first. Write it down. Understand and write. It's a simple integration, but I know a lot of people have lost touch to integration. They know integration. If I give you a problem, they'll do it fast. But in terms of realistic thinking, that is not there. Even I used to do the same. When I say integration of P dV, whatever the relationship between P and V, P used to come outside, and then I used to write V2 by V1. And worrying why I'm not getting the right answer. Then I used to switch off. This is what used to happen to me in engineering. Then I used to switch off myself, thinking that this is not my piece of bread. This is not something which is important. So what is difficult is not important. let me dump it. That was my attitude, and this is the attitude most of the students have even now. Correct? Just this, students. Tell me when you finished writing. Finished, everyone? Online students, did you finish writing?
Yes, sir.
Huh?
Yes, sir. Yes, sir. Yes, sir.
No, right? Write it down. Tell me when you finish. Kirtan, done? Kirtan,
Yes, sir.
done, finished.
Yes, sir.
Okay. So now, let us, Sridevi, I hope you're finished now.
Sir.
Yes or no?
Yes, sir.
Okay. So now, next, we have to consider x bar. Let us consider x bar again. So what happens here? This is z, correct? This is y, and this is x, correct? X, y, z, correct? And we had this over here like this, correct? This is our, so it is this way, okay? So now, the main thing, what is there here, was this was C, this was A, this was B. Now, can you perform integration on the other side? What is the elemental volume we have to take? Now here, minus Fr. Now taking moments or equating moments about y-axis. About y-axis. Very important to go for the details, because if you miss the details, you miss the concepts. Okay. Some people may feel it is trivial, but I'm doing it for getting the things through. Okay, I know a lot of people have a simple mistakes they do in understanding. Okay, so what you do here, you take an elemental volume here which is from the equally distanced from the what, from the y-axis, correct? So we are taking moment with respect to y-axis, correct? So we will take something which is equally distant from the y-axis. This is the element I am taking into consideration. Keep in mind, this is the element we are taking into consideration. Okay, and this element is at a distance of x and has a thickness of dx. Correct. So similar way, when we go in this fashion, okay, we can understand in this fashion when we do it, we can write your in the sense that I can have, say, minus Fr into x bar should be equal to integration, minus Fr into x bar should be equal to integration of minus x into what, x into what is the thickness of this, what is the volume of this, it is nothing but a into c by 2, correct? Am I correct? A into c by 2 into dx, that is the volume, correct? Volume of that elemental thing, correct? Then we have to multiply by rho g. Have I done any mistakes here, students? Just check it out. No, I suppose. Okay, it is a into c is the height, and divided by half, base into height into half, correct? So into rho g. So what is Fr here? Fr is the same, rho g into ABC by 2 into x bar, and here let us take all the constant outside, minus AC by 2 is a constant, rho g is a constant. What remains inside is, I think I missed something here, is it not? Yes, I have missed x into rho g. Yeah, integration of, yeah, you have to say, just a second, students. What did I miss here? AC by 2, correct? AC by 2. I have not missed anything, is it not, students? X dx, integration of x into dx. Nothing we have missed, correct? So where should we integrate? We should integrate from 0 to b, correct? No? Perform the integration and tell me what is the answer. Okay. Yes, to perform the integration and tell me what should be x bar. Fast, be fast.
But where is the function? Only the x is that. But last there was a two different
It was coming like that.
there was
It was coming like that. We did not do anything. It was coming like that, so we took it directly like that. What we try to do is we try to think that something can be done simple. Okay, we can simplify it. Sometimes we cannot. We should go to the actual case how it is, see it as it is. Okay, don't try to put what you say, a common thing that if it happens here it has to happen here. It may not happen. That is the whole point of it, is it not? Okay, whole point of testing, they do in this fashion only. They see where you miss, right? So that's how you can do. Now next problem comes in the Z. How will you do Z? This x bar, did you get it? Do it fast and tell me first. Integrate and tell me what is the x bar you got. B by 2. Very good. Okay. So you got x bar as B by 2. Did everybody get this? Yes or no?
Yes,
Yes.
sir.
Very good. I hope everybody got it. Okay. So let me switch off this one first. Okay. Now, okay. So x bar is equal to B by 2. Correct. Now what is Z? How do you take the Z now? It's important. Z bar. Where is the Z bar here? About which you are taking the moments? We are taking xy plane, but which point? See, till now what did we do? We took with respect to x, we took with respect to y, because the force was acting in that direction. Now on the z bar, where should it act? X bar, y bar is done. On the z side, where it should act? Yes, students, please. X bar, y bar, we have put it here. X bar, y bar is over here. Where should be the z? Which point should be the z? Should it act at above? Should it act down? Or where it should act? Correct? Good question. So it can vary only on that particular point, x bar, y bar, wherever x bar, y bar is there. Okay, say this is the location of, say, y bar, and this is the location of, say, x bar. Okay, this is the centroid, somewhere here. Centroidal line is somewhere here, you see. Where on that axis it should happen? See, we have found out x bar and y bar. So x bar, y bar, when we put on the zx, on the xyz plane, it is a line, because we can have z at different points. It can go from 0 to infinity. But now the question is, where should I place the z bar? With respect to which moment it is to be taken? Anywhere along that line, we should be able to place, is it not? That is the answer. You convinced with that? Convinced with that? Anywhere along the z axis, it will give the same moment. Correct? Agreed? Just let us understand. Anywhere along the z axis can it be placed? Let us see. So let us take it a bit bigger so that we will understand this better. It's not that easy to understand. Okay. But in general, what we can take is, it's in between that line we take. Okay. But what will happen if we don't take? So if I take a bigger thing like this, bigger block in this section, then the problem may happen. It's a bigger block here. Okay. If this is a bigger block, okay, and you say x bar y bar is along this line. Now you see this line over here is a point anywhere we should be able to take. That is a point is it not? Anywhere along this line we should be able to take the z bar. Why? Because it produces the same moment with respect to x-axis as well as y-axis. With respect to z-axis, it does not produce any moment. What should happen here? The thing it should happen is it should not create moments, or it should create an equivalent moment with respect to x-axis, with respect to y-axis. Now, if any force is acting in such a way that the moment about z-axis is not there at all. Suppose you have a point here. It's not about a point. It's about axis. We are talking about axis alone. So about this axis, if I have a force which is along that axis, a force which is along that axis, does it create any moment? It does not create any moment. With respect to this axis, it does not create any moment when the direction is along that. Exactly. So what happens? Z bar can be taken anywhere. But for convenience, now another point is there. What about points? What about individual points? We are talking about lines, it's fine. But then we have to take moment about point, is it not? So should we take moment about origin and have to check where should be the z placed, is it not? Because although moment about the line is not there, moment about a point is there, is it not, with respect to z axis? Where it should be? This is a big question mark which I'll answer in the next class. And you have to calculate the moment of these individual forces with respect to any point. Thing to be thought about, whether it should be in the middle of this one, x bar y bar is fixed, whether it should be in the middle and put the z bar there, or should we do it at the below here, or should we do it above? These are the questions, or somewhere other point. Because equilibrium means, or equivalence means, it should create the same turning moment at every point. Can you do this for an exercise? Hello, everyone. Okay, take moment about every point with respect to those and integrate it and see where should be z bar. This is homework. So we will meet again at 11:30. It is 11 now. We'll meet again at 11:30 with which subject? We'll meet with mean value theorems. Okay, so we'll stop here. We'll continue with Lagrange mean value theorem. We have stopped it there. We'll continue with Lagrange mean value.